hydrogen atoms that bond with an oxygen atom. These atoms are sharing electrons, which makes this a covalent bond. But here's the thing. Oxygen has 8 protons in the nucleus, and each hydrogen only has 1 pathetic proton in their nuclei. The ability for oxygen to attract the electrons is stronger than hydrogen's ability. This is known as electronegativity, but I think of it as electron bullying because oxygen is going to have the electrons around its nucleus more often than the hydrogens have the electrons around theirs. As a result, the oxygen side becomes slightly negative, and the hydrogens become slightly positive. This is an example of a polar covalent compound. The positive and negative ends create poles, like the ends of a magnet. But not all compounds have this kind of relationship. On the spectrum of bond polarity, non-polar covalent bonds share electrons very equally and don't create poles. Polar covalent bonds share electrons unequally and create dipoles, which also cause some intermolecular attractions. And ionic bonds are so polar that the electrons are actually transferred to the more electronegative element, and their charges attract them to one another, forming an ionic bond. Let's look at some examples of the covalent bonds. Non-polar covalent bonds share electrons equally. Examples include all of the Brinkelhoff twins, like nitrogen and oxygen and fluorine, but also other molecules like carbon dioxide that have atoms with really similar electronegativities. Polar covalent bonds, or just polar bonds, have bonding electrons that are shared unequally, like hydrogen chloride, which is also called hydrochloric acid. The chlorine atom attracts the electrons more than the hydrogen atom, so the chlorine becomes slightly negative and the hydrogen slightly positive. We can symbolize this partial charge with the Greek letter delta. Fluorine gets a partial negative, and hydrogen gets the partial positive. One of the most important polar molecules for life is water. These water molecules prefer to have opposite ends near each other. The slightly negative oxygen ends are near the slightly positive hydrogen end. The polarity of water makes it great at dissolving lots of different substances that are also polar. The water molecules have slight attractions to each other, and even to other molecules. These attractions between molecules are called intermolecular forces, and they are much weaker than either ionic or covalent bonds. But just because they're weaker doesn't mean they aren't important. Intermolecular forces play a big role in determining the state of matter of a substance, like solid, liquid, or gas. The particular intermolecular force between hydrogen atoms that are covalently bonded to a very electronegative atom that is also weakly bonded to another atom's unshared pair or partially negative region of a molecule is called a hydrogen bond. So it's basically the attraction between the partially positive hydrogen to the partially negative region of the atom. In this case, the negative region is oxygen, and that's a hydrogen bond. But bond isn't the best word, because it's so much weaker than an ionic or covalent bond. It has only about 5% of the strength of the average covalent bond, but it's still the word that's commonly used. These hydrogen bonds give water a lot of its unique properties, like its ability to form droplets, or maintain the surface tension when a water strider bug is on it. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe, and follow me on Twitter @SciencePet.